Tennessee? That's the state who borders Kentucky, North Carolina, Mississippi, Alabama, Virginia, Georgia, Missouri, and Arkansas. Tennessine, originally named unseptium, is the 117th element. Unmetalled, also an halogen with 117 protons and 117 electrons with 177 neutrons. Tennessine was discovered in 2010 by Yuri Ognesian with a density of 7.1 to 7.3 grams per centimeters cubed. Tennessine has a melting point of 623 to 823 degrees Kelvin and a boiling point of 883 degrees Kelvin, an atomic weight of 294 atomic mass units, and it was named after the American state, Tennessee. The Research Institute for Advanced Reactors, Dimitrovgrad, Lawrence Livermore National Laboratory, Oak Ridge National Laboratory, Vanderbilt University, Tennessee, and the University of Nevada, Las Vegas. Further experiments and analysis later confirmed this result, and the discovery was verified by UPAC in 2015. The element is named after the Tennessee region, in recognition of the contribution institutions from that American state played in superheavy element research. Tennessine was made by a fusion reaction of element 20 with element 97, calcium 48 with berkelium 249. In the first synthesis of tennessine, calcium ions were formed into a beam in a cyclotron, a particle accelerator, and fired at a target layer of berkelium deposited 300 nanometers thick on titanium foil. The first bombardment lasted 70 days. The berkelium was bombarded with over 7 trillion calcium-48 ions per second, accelerated to about 10% of the speed of light. The data showed 5 nuclei of interest were produced during the 70-day bombardment. As a consequence of the high energy of the impacts that created them, these nuclei instantly lost thermal energy by emitting 4 neutrons to form tennessine-293. The tennessine-293, approximate half-life 14 ms, decayed by alpha emission into element 115, moscovium. 2-3. In a second bombardment lasting 50 days, the speed of the bombarding calcium-48 ions was reduced. The resulting impacts were of lower energy, and the single nucleus of interest that formed needed to emit just 3 neutrons to lose its excess energy, leading to the heavier tennessine-294 isotope. The data showed 1 atom of tennessine-294, approximate half-life 78 ms, was formed in the bombardment, decaying again to element 115. As a result of its position in group 17 of the periodic table, tennessine is expected to have chemical properties characteristic of the halogens. The effects of relativistic electrons, however, may result in partial metalloid properties. Too little of the element has been synthesized for its chemical properties to be confirmed. Jim Roberto from Oak Ridge said, "New isotopes observed in these experiments continue a trend toward higher lifetimes for increased neutron numbers, providing evidence for the proposed island of stability for superheavy nuclei." Like I said, IPAC has accepted the discoveries of element 113, element 114, element 115, element 116, element 117, and element 118. Completing the 7th row of the periodic table. Tennessine is harmful due to its radioactivity. Tennessine is a synthetic radioactive metal and has only been produced in minute amounts. Tennessine is of research interest only. Tennessine can be produced by bombarding 249 Bk with 48 Ca in a heavy ion accelerator. Initial data has identified 2 isotopes of tennessine, with mass numbers 293 and 294. Neither are stable. Tennessine-293's approximate half-life is 14 ms and Tennessine-294's is 78 ms. We're almost there to the end of this series, so stay tuned for the last element, which is organism.